All right, in this video, we're going to take a look at how to identify your limiting reactant or limiting reagent in a chemical reaction. First, let's do a quick review of what a limiting reactant and excess reactant consist of. So remember, the limiting reactant is a reactant that is completely used up in a reaction. Once you run out of it, your reaction stops. So the limiting reaction is really reactant is what controls the reaction. If you run out, it stops. Doesn't matter how much of the other reactant you add. It won't do anything because you run out of one, so it's done. The excess reactant is the one that you have more than enough of. You have plenty of it, and it's usually going to be a leftover in the reaction vessel after the reaction is done when the limiting reactant stops. And so in the previous video, we had seen a bunch of analogies to go over the limiting reactant and what it is. And now we're going to take a look at the three different methods that you can use to figure out what your limiting reactant is and how you can identify limiting reactant problems. So let's go ahead and take a look at this little picture over here. And then we'll go over the methods of discovering your limiting reactant. So if we analyze our beaker, here's our beaker sort of before the reaction starts. We have two reactants in there. We have A plus B gives you C. And so a reaction is going to happen, and it does happen like this, and you'll notice that we get a bunch of C's produced. And so we have to figure out what is our limiting reactant. Is it A or is it B? So looking at the before the reaction and after the reaction, you can figure that out. You'll notice that you have a bunch of leftover A's. And so because you have leftover A's, chances are that's your excess reactant. So they remained unreacted because you ran out of B. You ran out of B. The B was all used up. And so because the B was all used up, the reaction had to stop. And so that's why you have your leftover A's. So the B is all used up. That makes the B the limiting reactant. Unfortunately, it's not always super visual like that. Sometimes you have to use math to support what your limiting or excess reactant is going to be. So the three different methods are listed over here. I'm going to do the first sample problem on your handout, not in completeness, but just to find what the limiting reactant is. That's what this video is going to focus on. In the next video, we're going to actually solve all the problems in your handout. So let's go ahead and see how we can figure out what the limiting reactant is for a question using each of these methods. So we'll do one method at a time. So we have how many moles of water are produced when 5 moles of hydrogen gas is added to 2.3 moles of oxygen gas. So the first step is essentially the same as any stoichiometry problem. Write a balanced equation out. So we have some hydrogen gas reacting with our oxygen gas. Remember, they're diatomic. And then they're going to produce some water. And let's just say, we could say it's liquid, we can say it's gas. We didn't really state it here. So that doesn't really matter too much then. So what we're going to do is we're going to write out our information that we're given. So we're given the number of moles of hydrogen. So N is equal to 5.0 moles. And we're also given the number of moles of oxygen. N is equal to 2.3 moles. And so what we need to do is make sure this is balanced before we proceed. So I think it is not balanced. We need a 2 here, a 2 here, and a 1 here. So now it's a balanced reaction. Now the reason this is a limiting reactant problem, I'm going to put a little star up here. I'm going to put LR problem, is because we're given the quantities of two reactants, and we have to choose which one we're going to use to figure out how many moles of water will be produced. Are you going to use the ratio between oxygen and water, or are you going to use the ratio between hydrogen and water? And so the one that you need to use is the one that will lead you to predict exactly what can be made, which is the limiting reactant. If you use your excess reactant, it may not, it will give you an overestimate of what you can make, which will be incorrect. So our first step is going to be to find the limiting reactant here. And I'm going to use a few different methods. So we'll try method 1 first. So method 1 is simply to divide both reactant moles by their coefficient. The smallest number is limiting reactant. So right off the bat, you can't choose the smallest number as your limiting reactant because the coefficients are different for them. It's not a fair comparison. So what you can do, and I'm going to do method 1 over here. We'll do method 1 in a different color. Let's do method 1 in red. So I'm going to put step 2. Determine LR. So I'm going to do the H2 first. So H2 you take the number of moles there, 5.0, and you divide by its coefficient, 2, and so you get 2.5. We don't care about sig figs right now. We just care about trying to make these more comparable to each other. We want to pretend like they're both on a 1-to-1 coefficient level. And then for the O2, I'll just do 2.3 divided by 1, and that's 2.3. And so now from here, we can say the smallest one after doing this will be our limiting reactant. So since O2, which is 2.3, is smaller than H2, which is 2.5, O2 is the LR. And so you would essentially ignore H2 and use O2 to finish doing the problem. So this is one method that you can use to find what your limiting reactant is. Just make sure you take the moles, not the masses, the moles of both reactants, and divide them by their respective coefficients. The smallest one is your limiting reactant. That's method number 1. Let's take a look at method number 2. So method number 2 we'll do in this green color here. Oops. So determine how much product each reactant could produce individually. The one that produces the least amount of product is the LR. So what we're saying is essentially do stoichiometry twice. So find how much product you could make with the H2 using stoichiometry, and find how much product you could make with the O2 using stoichiometry. The one that made the smallest amount is your limiting reactant, because the other one that made more, you overestimated. Okay, so let's go ahead and do that. So this is going to be step 2. Technically, this step is going to allow us to solve the problem at the same time. So determine LR. This is method 2. So these are not different steps into it. It's really just the same step, finding the limiting reagent, just in different methods. I want you to understand that. So let's go ahead and try that out. So we're going to do, first we'll do the comparison between H2 and H2o. So for H2, I'm just going to put that here. Our ratio is a 2H2 to 2H2o ratio. And so we could reduce that to 1H2 for every 1H2O. So it's a 1-to-1 ratio here. And so we can use that ratio to figure out how many moles of H2O should be produced with 5 moles of H2. So we can simply do 5 moles of H2 times our ratio, which is 1 mole of H2O over 1 mole of H2. Cancel out the H2s, and you get 5 mole of H2O. So that's a 2-to-2 ratio there, and we get 5 moles of H2O produced. Okay, let's take a look. What if we decide to use the oxygen to make a prediction? What would have happened? So if we're using oxygen, oxygen is a 1O2 for every 2H2O ratio. And so that would be, we have 2.3 moles of oxygen, moles of O2, and we're going to multiply it by our ratio, which is 2 moles of H2O for every 1 mole of O2. Cancel O2 out, and we get 4.6 moles of H2O. So now we compare which reactant made less product. Well, when we use the oxygen to predict the product, we had 4.6 and the hydrogen 5. The oxygen made less. So since oxygen produced less product than H2, O2 is the LR. And technically, you've already solved your problem here. The whole point was to find the number of moles of H2O produced by this reaction. So O2 will react and run out, and there'll be leftover H2. We'll figure out how to find that later on, but the point is it'll make 4.6 moles of H2O. So you could even finish up the question here by saying, therefore, 4.6 moles of H2O are produced. And that would be the end of your problem. So that method 2 is a bit quicker in this case here, as long as you're pretty quick with doing some stoichiometry problems. So that was method 2, just to find the smallest amount of product made, and that's your limiting reactant overall. And when you're doing these problems, you really need to state, which one is your LR. You have to be clear with that. So this is my LR, and then over here, this is my LR. Now, if I was not if I chose to do method, the red method over here, method 1, what you would have done with this, with the O2 as the LR, is you would have then taken your 2.3 moles here, and you would have done a mole ratio to find your moles of H2O produced, and you would have gotten the same answer. So I'm just going to show you that. I'll just go ahead and do it, and then we'll do step 3. I'll just erase everything and do step 3 after, or method 3 after, sorry. So if I was doing, let's continue the red down here. Okay, pretend the 2 is not there. That was just another method to do. So if I was doing the red method, I would have found my LR. And so now step 3 would have been use LR to predict product. And so you wouldn't have used the divided version. You would have used the undivided version, okay, the one that you're initially provided in the question. So you would have done your mole ratio between them. It's a 1-to-2 ratio. So just a note here, O2 is LR. And you would have done that you have 1 O2 for every 2 H2O. So you would have said you have 2.3 mole of O2 multiplied by 2 mole of H2O for every 1 mole of O2. Cross out moles of O2, and you would have had 4.6 moles of H2O. And then you could write your therefore statement. So therefore, 4.6 moles of H2O are produced. So, and this is to 2 sig figs, which I think you were given that in the question. So we have 2 sig figs is what we use for our limiting reactant. So that's what our final answer should be rounded there to. So what we just saw were 2 methods to find the LR. The first method is just divide both moles by the coefficient, and that gives you the LR. Then afterwards, you'd have to go with that limiting reactant and do a mole ratio to find what the amount of water produced is. So the whole point of that was just to find limiting reactant so you can make the prediction. The other way to do it is you're kind of doing both steps in one. You're checking with both reactants how much product you could make. And the one that you have more of would not be your LR, it would be your excess reactant. And then the one that you have less, the one that produced less, would be your limiting reactant. And so by doing this, what you actually did is you solved most of your problem. You found your limiting reactant. You said O2 was your limiting reactant, but you also found how much it made, how much water it made. It made 4.6 moles of water. And so you're technically done your problem at that point there. You might want to use, method 1 in a multiple choice question, for example. And you might want to use method 2 where it's a simple, find the mole ratio or find the amount of moles only when you're showing your work. So it really depends on your comfort and preference as well. We're going to do one more method. I'm going to show you the last method. It's method 3. Compare the mole ratios of the reactants used. The one that requires more than what there is in the question is the limiting reactant. That was a bit confusing, but let's show you to do that. So I'm just going to erase the first 2 methods that we did, and then afterwards we'll do method 3. So let's go ahead and do that. And you can always rewind if you need the practice. So we want to find the limiting reactant, and we're going to use our new method, method 3. Whatever method you're comfortable using, you can go ahead and use that method. It really does depend on what the objective of the question is. Method 3 is going to be particularly useful when we're trying to find how much leftover there is at the end. All right. So the first step's the same, regardless of what method you use. You want to have your balanced equation. You recognize the limiting reactant problem because you have two reactants given to you as opposed to just one. And then you have to choose a method that you want to use to find your limiting reactant. And so again, we're going to do method 3. We're going to compare the reactants to each other. So there's actually two ways that you can do method 3, and they'll both give you the same answer. Just you'll have to interpret it a bit differently. Method 3 is a good way because it shows you that you understand the concept of limiting an excess reactant a little bit more. And so I recommend you do get practice with all methods so you at least understand how to do them if you need to do them. Okay, so here we go. So what I do for method 3 is I'm going to choose one of my reactants. It doesn't matter which one. Let's do method 3 in this purple color. So choose a reactant, doesn't matter which one. Let's choose, so step 2, determine LR. We're going to choose O2, okay? So we have 2.3 moles of O2. So what I want to do is I want to find out how many moles of H2 should react with it. So I have 1 O2 for every 2 H2. In the question, I said I have 2.3 moles of O2. So if I want to find how much H2 should react with it, I can just do a mole ratio. I can just do my 2.3 moles of O2 multiplied by 2 moles of H2 for every 1 mole of O2. And so I can cancel out the moles of O2, and I get 4.6 moles of H2, which should react with the O2 that's there. Now look at what you actually have. So this is what will react. Okay. Now take a look at what you actually have, which is 5 moles of H2, is larger or smaller than what will react. Notice that you have more than what will react. You have 5.0 moles of H2. That's more than 4.6. So since you have more H2 than needed, that's going to make that your excess. So since have, which is 5.0 moles, is more than what will react, which is 4.6 moles. H2, you have more than you need. H2 is the excess reactant, which makes O2 your limiting reactant. And you can say, therefore, O2 is the LR. And so what you'll notice is you have about 0.4 more than what you need. It's still an excess nonetheless. So that'll be left over in your little reaction container. About 0.4 moles will be left over at the end of the reaction once everything is reacted. This is one way that you can do that. And then once you've found the limiting reactant, then it's all the same going forward. So then you're going to do use LR to find or predict product. So you're going to do the same idea. You're going to say, well, O2 is my LR, so I'm going to have 1 O2 for every 2 H2O. You're going to use the moles of LR, so which is O2, so 2.3 mole of O2 times your conversion factor, 2 mole of H2O over for every 1 mole of O2. Cross out the moles of O2, and you get 4.6 moles of H2O. And then you can do your therefore statement. So therefore, approximately 4.6 moles of H2O are produced. So in this method, you just chose one of your reactants and then found how much of the other reactant is needed. And you say, okay, well, if this is how much of the other reactant will react, let's see how much of the reactant I actually have. I have more than I need, so it's the excess. I'm going to show you you don't have to do both of these, but essentially what would have happened if I didn't choose O2? What would have happened if I chose to work with the moles of H2 instead? So it's kind of the same step. It's just you interpret it differently. So let me show you what I mean by that. So same idea. We're going to say that for every, so here I chose O2 to work with first. Like I said, if I have 2.3 moles, how much H2 would I need? Here I'm going to choose H2 to work with. So I'm going to do the same idea. I'm going to make a mole ratio. I'm going to say there's 2 H2s for every 1 O2. And so what I'm going to do is I'm going to take my moles of H2. I'm going to say if I have 5 moles of H2, how many moles of O2 should react? So I'm going to find how much O2 should be reacting with it by doing my multiplication times my ratio, which is essentially 1 mole of O2 for every 2 mole of H2. Cross moles out, and I'm basically just doing 5 divided by 2, which is 2.5 mole of O2. And this is how much O2 should react. And I should have said should react here as well. Should, because that's assuming we have it there already. Okay, so should react. And in the case of my previous one, will react was correct because that's how much will actually react there. Here, if I'm looking at my 5 moles of H2, how much O2 should react with it? Well, and according to this reaction, 2.5 moles of O2 should react with it. But let's take a look at what I actually have. For O2 in the question, it says I have 2.3 moles. I don't even have 2.5 moles of O2. So what's happening here is since you have, which is 2.3 moles, is less than what should react, which was 2.5 moles, O2 is the LR, and then your H2 is your ER. Notice it's essentially the same result in the end. You just have to interpret it differently. In this case, you're going to say, well, what should react is more than what you actually have. In this case, when we chose the O2 to go with is what should react of H2 is actually less than what we actually have. So in other words, we're going to have leftover H2s. So again, these are the same method. I just showed you that you might get a different result, or not different result, but different interpretation, and therefore different way to look at the sort of the result, but still get the same answer in the end. Your O2 is your LR and your H2 is your ER. This one here told us what our ER was, and then afterwards told us what our LR was. This one here just told us directly what our LR was, and that's about it. And it would have been the same thing. You choose your LR after to find your number of moles of product, and that's about it. So when you're doing your questions now, you can choose any one of these methods to use to figure out what your LR is first, then use your limiting reactant to continue the rest of the problem. And basically, you can ignore the excess reactant after that. You can pretend that number is not even there unless we ask you to do something with it later on. So in this video, we saw the 3 methods of determining the limiting reactant. In the next video, we're going to do a few more examples of problems where you might have to find limiting reactant. As I do those examples, you're free to choose any method that you want to find your LR. I'm going to do different methods and different questions. And you can just see if you're on the right track, and you can compare with what I'm doing.